Here we are again on Linux and wanting to have a play on Space Engine. So let's get Space Engine started and we'll have a look just to see how small Earth is in the universe. Space Engine is pretty good. Apart from it only renders our solar system in HD, but it's still playable. So, right, so let's jump on. Okay, so let's go and find Earth. No, let's see if we can type correctly this time. There it is, Earth, Moon, Planet. Right, so you can see all the statistics of the planet on the top left hand side here. Okay, so here's Earth. So it's as you'd expect it. We'll go a little bit faster just to zoom around. So changing my velocity there, and we can see. There you go, there it is. Spin around and you can see all the countries. And he's pointing towards the sun, which is here, and that's the sun. And you see these lines here that's switched on by the orbits I've got turned on. So we turn the orbits off and we see Earth. But then you look at where the moon is. Now we see the moon in the sky, don't we? Sometimes it looks closer, sometimes it looks farther away, but at the moment we can't see our moon. So let's see if we can trace where our moon is. So we put on orbits again. We're going to zoom out a little bit. And we see the epicenter of the Earth, which is in red there. But we can't see our moon. So what I'm going to do is I'm going to speed up a little bit. Now we've come out quite a long way away from the Earth already, but let's speed up. And there we go. There is the moon. So we think that the moon is quite close, but it is actually quite far away. So we can go to the moon here and we can have a look at it, and we can see on the orbits that we know the rotation and where they're going to go. So that is the moon. Slow down a bit so we can get a little bit smoother action. So again, there's the moon. And trying to find out where the Earth is going to be difficult again, but the Earth is, where did it go to? No, that's the moon still. Let's just zoom out a little bit. Actually, there it is, yeah. So there's the Earth. So as you can see, it's easy to get lost with planets because they're that vast. So this is our solar system. So we're going to just turn off the orbits again and we're going to zoom out a little bit. You can see that the solar system is there. If we zoom out, it looks like there's like nothing else near us, just the Earth, the moon. But if we scroll sideways like this, we can actually see other planets as well. We turn the orbit on, see what these other planets are. Well, this planet here, that is, and no, that says it's an asteroid, but I haven't selected it right. Let's try again. Okay, planet Mercury, that is. And we'll be able to see all of the other planets. Let's get a better view of this here, and we can zoom out a little bit. Okay, so there we've got planet Mercury. We've got another one here. What's this one? That's the Earth. That's the moon of Earth. That's the one we've just seen. We've got this one here. Nope. This is the problem sometimes. So many different stars. You click on things accidentally. That's planet Venus. That's planet Mars. We've got Ceres there, dwarf planet Ceres. We've got planet Jupiter. We've got planet Saturn, and we can actually zoom in to see all these as we did before. Let's go and take a look at Saturn. The Saturn is like an aesthetic planet to look at, and people like looking at Saturn. So let's go into here like this, and we see all of the moons that are rotating around Saturn. So we've got this one, it's Tethys. We've got this one, that's the planet Saturn. We've got this one, Janus. We've got this one here, so that one. All the Saturn's moons. We've got Titan. Titan's the biggest one, I think. So you can see, like, this is what Saturn looks like. It's got all these little planets just rotating around it. Turn the orbits on, we can actually see like the path they take around Saturn, and all these different moons that are around Saturn. It's quite amazing, really. So that's our solar system. So what we're going to do is we're going to zoom out a little bit. We're going to turn the orbit back on and then just see how far we can go out. So that is Saturn there. We've still got our sun. We're going to speed up a lot here. That's our solar system. So I'm going 13 astronomical units. I'm increasing the speeds just so we can get an idea of how far away we are from everybody. That's our solar system there. And you'll see it, and it starts getting dimmer and dimmer and dimmer and dimmer as we zoom out. And we're going quite fast now. We're going 4 light years a second. We see all these other planets here. So what planets are actually local to us? Well, we can't see that many, but we've got this one down here, which is moving quite fast. And that's Alpha Centauri. So we can go and see Alpha Centauri. And I think that's our closest main star, and it's a binary star. So we'll just have a quick look at that here. And once we get in, we've got to slow down. I don't want to go past it. Can use G on the keyboard to go. Oh, there you go. I've gone past it. So can use G on the keyboard to go in a little bit slower, but we'll just use this way. Okay, so now we've got these 2 planets here. This is Alpha Centauri, and this is a binary star, so they're kind of working in tandem. And if you look at the actual orbit, which I'll put on in a second, there you go. It's Alpha Centauri. We'll take a look at the orbit that they take, and that's basically what you get. So kind of 2 circles rotating together. So, and that's all that is there. But a lot of the time you have these planets and these little dots in the sky, and you basically think they're just a star, but some of them are actually solar systems, like all these planets. And you think, oh, there's not that many solar systems really. We're not close to anything. And that's true, we're not close to anything, but the amount of time it would take to get from Earth to this planet will be years and years with our current propulsion systems that we've got. So let's just zoom out a little bit and just get a scale for how big our solar systems are and how many there are and how big the galaxy is. So this is basically just coming out, and we see, oh, my battery needs changing soon. We just see how many different stars and solar systems there are in this galaxy. It's just crazy. And we see we're in the middle of the Milky Way here, and we can go forward and we can go backwards. So we just zoom in. So I'm going to speed up a little bit here. And we're going to go towards the center of the Milky Way. And we just do this. And we see all these things in the sky, don't we? But we don't actually know what's in there. You've got all these weird objects sometimes in the sky. Like you got this cluster here. I can actually click on it. There you go. So Nebula Carina. So we go to Carina Nebula, Grand Nebula, NGC 3372. Have a look to see what's in here. And you can see like all the M42 nebulas and all the other nebulas that you usually see in the sky with the telescope. And you've got all this gas in here, and we can see that there's some very, very bright stars here. I don't know whether these are going to be solar systems, but we'll have a look. We'll take a look at one of these. Let's try this one here. It's quite small, isn't it? So I'll zoom in a little bit. It looks like we're going really slow, but we're actually going quite fast. I think it's because the size of these planets make it feel quite slow. Okay, so this looks like a sun, but from a distance it looks like a single planet. But you see, as we zoom in and we turn the orbit on now, we've actually got quite a lot of planets rotating around this. So we look at this star, and this is a binary system as well. Look, so you've got 2 suns there. And we can see the temperature of these suns. So we click on this one here, and the temperature of this is 4,116,000 degrees. Okay, so you might be able to get a suntan off that. And if we go to all these planets, we can see the statistics of all these planets here. So this one is quite close to its main suns, and this temperature is 73 degrees, so it's not too bad. Not as hot as the one in the middle. And then you've got statistics from other planets as well. And we can just basically see what the characteristics are of all these other planets. So that's an asteroid, that's an asteroid. What's this one here? Let's have a look at this one. That's the barycenter. And we've got, and that's another barycenter there. So we've got a couple of things rotating around there, but I don't think they're like normal planets as we'd expect them to be. So you can basically just go and have a look around all these places here, and we'll speed up again, and we'll actually look at this one over here. What's this one? Ooh, this looks interesting. You got lots of planets in the middle here. I'm going really fast at the moment, so I'm in 5 light years a second. I'm slowing down a little bit. You've just got all these clusters in the sky. So this is like how planets are formed while gas is in the air and the gravity increases and then compresses it, and then there's a big explosion, and there you go, a planet is formed. I think this is just some of the dust that's left from there. You notice like all these planets are in like a concentrated area. They're not distributed around like all the other stars are. That just gives you an idea of like how big the solar systems and the galaxy and the universe is. But we haven't actually looked at the universe at the moment. So we are in the Milky Way at the moment, and we can see all these different stars, and each one of these stars represents the solar system. Some are big, some are small. We can actually look for local planets if we want. So let's do a star browser, and I want to search 10 light years, and I'm going to search for every single planet 10 light years from my location, and we've got this one here which has got 14 planets, and we've actually got this one here which has got life on it as well. So we go to this one here. Let's see what this gives us. You can notice that this is just a random star out in the middle of nowhere, similar to what we've got in on Earth in our solar system. And you'll notice that there's more planets here, and we can see what planets look like just by going to the browser. Yeah, so we've got the local solar system browser, and we've got all these different planets here. And we click on this one, this thing here. Okay. So we've got, it looks like we've got an orange dwarf star, which is nearly 4,000 degrees. We've got this one here, which is a star, and what's the temperature of this one? It's quite hot. And we've got this one here, which is RS8513. And was this the one it said it had life on? I don't know. Anyway, so it just gives you an idea. There's like loads of different stars out there with different compositions of planets. So what we're going to do now is we're going to zoom out of this galaxy. So now we're still in the Milky Way, but we're going to bump up the speed a bit now. We're going 7 or nearly 8,000 light years. So what we do, we come out of the solar system, and we can see all these galaxies. So that is the Milky Way there. I'm going to speed it up even more. So we zoom out of the Milky Way, and we see what looks like other stars, but actually what these are other galaxies. So I'm going to go like a couple of million light years, and I'm just going to choose something random. What should we choose? Let's choose that one. That looks like a little star, doesn't it? But we know it's going to be a galaxy. So let's go to that one. So I'm going to travel there, use the automated travel. And it's going to take me to this galaxy, and what's it going to give me? Okay. Ooh. It's like a Christmas tree with blue lights. Okay, so let's zoom in here. And we've got lots of blue lights, but you notice the gas is coming back again, and this is another galaxy. We are now in another galaxy. We're still quite fast. We need to slow right down now. Slow down. And we've got all these other stars. So this isn't as big as the Milky Way, but we do get a lot of stars, and then again we can go into a very small. This one's quite small. So that one's tiny. There, it's an orange dwarf. Let's just go to that one. We'll see what is actually in there. I've just turned the orbits off just to see what it looks like. It's disappeared. Oh, there it is. Okay. So we've got this planet here. I don't know if it's got any associated planets around it. Oh, it does. It's got all these. So we see this thing and it's like a very, very small dot. But you notice that there's all these other planets dotted around it. There's like all these asteroids, and you've got, what's this here? Look at this. Look how many moons this planet's got here. Look at that. Imagine living on a planet. You got this many moons. So yeah, that's a nice green planet. So that just basically gives you an idea of how big the galaxies are and how big the universe is. So you see how many different stars are out there, and then the conversation of, is there extra life out there, or life on another planet? Yeah, there could be, but if there's aliens coming to Earth, which people think actually is a thing, like they've got to find Earth from all these remote locations. So how do they locate that? It's going to be very difficult, especially when you're talking about the scale of all this. We go through the universe like we're going at the moment, then really, can we guarantee that people are actually targeting Earth when we're so kind of minute in a massive, massive field of stars and galaxies? So I don't know. But anyway, that's Space Engine. And yeah, it gives you an idea of the scale of things, doesn't it? Right. Thanks for watching. See you later.